So following on from some of our earlier videos, we were using this as a model for our golf game. So we were using this as a model for our golf game. So we were trying to find out we were trying to find out which ring is most likely to land in when you hit the golf ball. Okay, so to do this, by right we should look at the probability, but we want to keep things simple. So we just consider this bit here because if this thing here represents the volume of the shell being rotated 360 along the y-axis. So this thing here represents the volume of the shell being rotated along the y-axis, and then this thing here represents the whole volume. So it represents from 0 to infinity. Hang on. So from 0 to infinity, being revolved around 360 along the y-axis. So this thing here represents the whole volume. So it represents all possibilities. This thing here represents the volume of one particular shell. So in the range of 0 to 5, we would integrate this thing here from 0 to 5. So if we want to investigate from 5 to 10, then we would integrate it from 5 to 10. And then this thing here, if this thing here is big, then it would automatically imply the probability is big because we're dividing by the same thing each time. So we would only consider this bit here. We want to keep things simple. If this thing here is big, then it would automatically imply that the probability would be big. If this thing here, which is the volume of the shell, if this thing here is small, then it would automatically imply that the probability would be small. So we would consider each segment. So from 0 to 5. So we would consider from 0 to 5, and then we worked out the volume of this thing, and then our next step would be from 5 to 10. So from 5 to 10, and then our next step would be from 10 to 15. From 10 to 15, and don't forget, this here represents the whole ring around here. Well, anyway, we got to this stage here. So this number here, these numbers here represents the volume of the shell. Okay, so these numbers here represents the volume of the shell. So it represents this. Okay, so we got to this stage here. Now, if you plot that on a graph, it will look something like this. So from 0 to 5, it would give us a volume of this thing here, and then from 5 to 10, it would give us this thing here. So really, to answer our question of which ring it's most likely to land in, we would consider the highest one, which happens to be in this region here. Okay, so if you were we in the previous video we got to this stage here. If you were to plot this, it would look something like this. This is not to scale. I made this up. So it would give you some sort of shape like this. Now instead of looking at the segment from in steps of 5, perhaps we can narrow this down. So instead of steps of 5, we could narrow it down to steps of, let's say, 0.25. Maybe we can go even further and decrease it and just look at the step of in steps of 1. So if we were to decrease this each time of the way, if we were to keep on decreasing it, it would look something like this. Well, if we keep on decreasing it, eventually it would give us if we keep on rather than looking at it in segments of 5. So from here to here is 5, and this here is from here to here is from 5 to 10. Rather than looking at it in segments of 5, if we keep on decreasing it, eventually it would give us a continuous representation. It would give us something like this. So this here is on a continuous level. So really you want the highest point here. So this here is on a continuous setting. This here is in segments of 5. So you really want to decrease this each step of the way. So eventually, if you decrease it long enough, it will it will give you a graph that represents that represents on a continuous level. Okay, so let's go back to this. Let's go back to the beginning of time, so to speak. Um, so let's go back to the beginning. We were trying to investigate this, and as we uh, uh, so we want to consider it in steps of five. So earlier we considered it in steps of five. If we were to decrease this, so from well, if we want to make this smaller and smaller and smaller, eventually it would give us it would give us a continuous continuous setting. I will continue in the next video.